Now, based on these shortcuts, we are going to draw different kinds of graphs for two situations. And those situations are a ball thrown up in the air and ball thrown down into the ground. We have to draw velocity speed graphs as well as displacement distance graphs for each of these cases. So let us start with the first situation, a ball thrown up in the air, and let's draw velocity and speed graphs. Have a look at this diagram. So we have a ball which is projected upwards with a speed of 10 meters per second. So it is launched from the point A. The ball goes upwards until it reaches a point B. B is the maximum height reached by the ball. Now, since the point B is the maximum height, so the velocity of the ball at that point will be zero, after which the ball will start to fall back down towards the ground. And now you can see the ball is falling downwards and it crosses the same point. So, actually, in this case, A and C are the same points, but just for the sake of explanation, I have drawn two different lines, one line for the upward going motion and another line for the downward going motion, but both of these motions are happening in the same line, and hence A and C are actually the same points. Since the ball was launched at a speed of 10 meters per second going upwards, now if the air resistance is absent, then the velocity at the point C will have the same magnitude. So at C, the ball would have a speed of 10 meters per second, but going in the downward direction. But please remember the assumption. The downward velocity and this upward velocity will be the same if you do not have any air resistance. So the ball crosses the point A upwards and the ball crosses the same point while going downwards with the same speed, but of course the direction is different. Now to summarize, ball is going up from A to B, then it comes down from B to C, and please remember C and A are actually the same point. Just for the sake of understanding, I have drawn two different lines. Now, how do we draw the velocity time graph for this situation? So this is A to B upward motion and B to C downward motion. At the point A, velocity is positive 10. Since the motion of the ball is upwards, but the gravitational force is downwards, that's why the ball is decelerating. So initial speed was 10. It keeps reducing until the speed becomes 0 at the topmost point. So from A to B, the graph will look like this. Velocity at A is positive 10. It keeps reducing until it becomes 0. And now, why the graph is a straight line? Because the acceleration value is constant. Remember the acceleration due to gravity, the 9.8 meters per second square? Since that value is a constant, that is why the graph or velocity time graph is a straight line but having a negative gradient. In this case, since the velocity is decreasing. Now, coming back to the topmost point, the velocity is zero. But then, what is going to happen when it is falling down? It is going to speed up because the ball is going down, which is the same direction as the force of gravitation. So the gravity is going to pull the ball downwards. Hence, we say B to C is accelerating. At B, the velocity is zero. And then while it is going down, the velocity will keep increasing in magnitude. But notice the direction of velocity is downward. So velocity will be negative. Hence, the graph will look like this. At the point B, the velocity is zero. From that point onwards, as the ball keeps going down, you can see velocity becomes negative, but the magnitude of velocity keeps on increasing. And at the point C, the velocity is the maximum, which being 10, or rather negative 10 to be specific. Negative represents that the velocity is downwards. This was the velocity time graph. Sometimes in the exam questions, they might ask you to draw the speed time graph. The only thing which you need to be careful of is distances are always positive and similarly speeds are also positive. So from A to B, velocity graph was above the time axis. So from A to B, the speed time graph will look exactly the same. But from B to C, velocity was negative, but speed cannot be negative. So what we'll do, we will take the reflection of this graph BC with respect to the time axis. So consider the time axis as the mirror. Try to draw a reflection graph for BC, and hence the graph for the speed time graph will look like this. And let's analyze this. Speed of the object, speed of the ball at the point A was 10. It keeps reducing until it becomes 0, and then it is speeding up. From 0, the value keeps on increasing to 10. But since we are dealing with the speed time graph, speed cannot be negative. Hence, the graph will completely be above the time axis. And that is how we draw the two types of graphs for when the ball is thrown up in the air. Next, we consider how to draw the displacement and the distance graphs for the same situation, a ball thrown up in the air. Now, remember the shortcut for displacement. How do we draw? If the acceleration value is positive, then the graph is an upward facing parabola. If acceleration is negative, then the graph is a downward facing parabola. In this case, during the entire motion, while the ball is going from A to B or B to C, the acceleration is negative 10. Now, since the value of acceleration is negative, that is why the shape of the displacement time graph will be a downwards U. So, how do we draw the graph? Before we draw this downwards facing parabola, remember whenever we are dealing with a displacement time graph, the origin point is important. So you need to specify what is the origin. So here, consider the point A is the origin of the motion. So what does origin even mean? So point A will be considered the point where displacement is equal to zero. And while coming down from B to C, the displacement value will decrease. So overall, if you analyze the complete motion, A to B, B to C, acceleration is negative throughout. That's why the shape of the graph will be a downward facing parabola looking like this. But let me repeat, A was the origin. That's why the graph is starting from the origin point at A. So this was the displacement time graph. Now, how do we draw the distance time graph? Remember the shortcut. All we need to check is the object accelerating or decelerating? So let's read. From A to B, which is the upward going motion, the ball is of course decelerating since the speed is reducing from 10 to 0. And since the ball is decelerating, we can say the shape of the distance time graph will be a downward facing parabola. So if we need to draw the graph only for A to B, which is decelerating, so it will be a downward facing parabola looking like this. But what happens from B to C, which is the downward motion? From B to C, the ball is accelerating. And whenever the particle is accelerating, shape of the distance time graph is an upward facing parabola. But please do remember, distance is a scalar quantity. It cannot decrease. It can either stay constant or it will increase. Now, since we need to draw an upward facing parabola and distances always increase, that is why from B to C, the graph will look like this. So please remember the basic distance cannot decrease as it is a scalar quantity. Now, in the exam question, let's say if the graph is directly given and you're supposed to read the graph. A to B is a downward facing parabola, so we can deduce that the ball is decelerating. B to C is a part of an upward facing parabola. That means the particle is accelerating. And over here, let's say the question has directly given you the graph. Since the graph is a downward facing parabola, which means throughout the entire motion A to B to C, acceleration value is negative. And that is how we determine what kind of motion the particle is doing based on graphs. But please do remember, while drawing the displacement time graph, the origin is extremely important. So we had deduced that even though acceleration is negative, which means the shape of the graph is a downward facing parabola, but the origin is important. If you are considering A as the origin point, that means the graph is going to cut the origin at the point A. On the other hand, let us consider B as the origin of the motion. So over here, the topmost point is the origin, which means the point A and C, since they are below the origin, the displacements at A and C will be negative. And how will we draw a graph in this situation where the B is the origin? Remember, the shape of the graph will stay the same. It's a downward facing parabola. But since B is the origin, the graph needs to cut the x axis at the point B. So have a look. At the point B, the displacement is zero since the graph is cutting the time axis. And you can see at the point A, displacement is negative. At the point C, displacement is also negative. Bear in mind, in this situation, A and C are actually the same points. And this was the complete analysis for a ball thrown up in the air. Now we'll do the same graphs, velocity speed graphs, as well as displacement distance graphs for the ball when it is thrown down into the ground. This case is a little tricky than the previous case. How do we draw? So let's look at this diagram where the ball is, let's say, thrown from a point A. So the ball is thrown downwards with a speed of 10. But since the velocity is downward, so the velocity will be negative 10. Now the ball is thrown down, it is going to follow a straight line path until it hits the ground. So ball is thrown down from A to B, it is going to rebound on the ground at B and then it goes up from B to C. At B, the ball is going to rebound and it is going to go back up. Now, in this situation, the ball is not going to go to the same point from where it was released because, of course, some amount of energy will be absorbed by the ground. So, the release point and the final point, those points are definitely not the same. Now, the ball can reach to the same point where it was released from if the ground does not absorb any sort of energy. Now, in the real world, it never happens. This point C will always be lower than the release point in the real world. And how do we draw the velocity time graph in this case? So, from A to B, the velocity will increase because the ball is going down as well as the gravitational force is down. So, gravity is going to accelerate the ball. But remember at the point A, velocity is downwards, so it will be negative 10. So the graph needs to start below the time axis. But while it is going from A to B, the magnitude of velocity definitely increases. And hence we can draw the shape of the graph like this. So from A to B, since the ball is going down, so the velocity will always be negative, but magnitude of velocity will keep increasing from A to B. Now at the point B, the ball hits the ground, which means instantaneously the ball will come to rest. Now, let me repeat, when the ball is thrown down and when it hits the ground, instantaneously for a short amount of time, the ball will come to rest. And what will happen just after that? So, look at this image. Just after the collision, the ball goes upwards, and upwards direction means velocity is positive. So, just after B, the velocity time graph needs to go above the time axis since it is upwards positive. But while it is going up from B to C, the particle ball in this case is decelerating. At the point C, velocity will be zero. And hence, from B to C, the graph will look like this. So, this is the point just after B where the velocity is positive. The velocity will keep reducing until the ball comes to rest at the point C where the velocity is zero. The only catch while dealing with this kind of a graph is when it is rebounding with the ground, the direction of velocity is changing. Initially, before hitting the ground, the ball was going down. After hitting the ground, the ball is going up. Now, since the direction is changing, that is why the sign of velocity has to change. Initially, the velocity was negative, but after the rebound, the velocity became positive. And that's how we draw velocity time graph. Now, let us try to draw the speed time graph for the same situation. All you need to remember is the speed time graph is similar to the velocity time graph with an addition that speed can never be negative. So the speed time graph will need to be completely above the time axis. Hence, if you look at the velocity time graph, B to C is already above the time axis. So the speed time graph will look the same. But the graph for A to B is below the time axis. So we need to take the reflection of this graph above the time axis. Basically, we need to make sure that the graph needs to go above the time axis. So how do we do that? A to B, the graph will look like this. So this is nothing but the reflection of this graph about the time axis. Now, what will happen from B to C? We already know the shape of B to C will look like this, but there is a slight difference. Now, try to use some basic logic. If the ball is thrown downwards at a speed of 10 meters per second, let's say when it is just about to hit the ground, hypothetically, let's say it hits the ground with a speed of 20. So just before hitting the ground, if the speed is 20, then just after hitting the ground, the speed will be a little lesser than 20 because some energy is going to be absorbed by the ground. That is why if you look at the graph, this particular point refers the point which is just after hitting the ground. And that is why you can see that there is a drop in the speed. And this drop is happening because the ball was colliding with the ground and the ground absorbs energy. After that, B to C, the shape of the graph will be a straight line going downwards. So C is the point, which is the highest point of the ball where the speed will be zero. And that is how we draw velocity time and speed time graphs for a ball thrown down into the ground.